What's happening there? There you go. So what I wanted to see here for the difference between theoretical and experimental, right? Theoretical probability, right? Likelihood of an event happening based on what? This is important. Based on total possible outcomes. So I don't want you to say, yes, you can say this is basically what should be happening, right? But this is what I'm really looking for here, total possible outcomes, right? Versus experimental probability, right? Likelihood, I'm going to skip some of that, of an event happening, right? Based on actual trials, polls, right? Experiments. We're going over the quiz, okay? So that's basically what I was looking for there. I think that would be very good to have on your study sheet. It might be multiple choice, it might be fill in the blank, you name it, right? You need to be able to, like if I said, hey, if we come up with a probability where we would consider a bunch of people being polled, right? What kind of probability is that? Oh, we're actually asking people, it'll be experimental probability, right? So that's what I want you to have on there. And also know this, that they may be different, and that's primarily due to the sample size. Like the sample size has to be large enough, right? Once it's large enough, then they should be roughly the same. That should be a slam dunk, hopefully. Then here, for the second question, it was asking the probability of it not raining. So some of you missed that. You went 40, right? Not raining would be there for 60%. So 0.6, which is 6 out of 10 or 3 out of 5. So if you missed that, I still gave you 2 out of 3 because you're still going through the process of getting decimal and fraction. Jen has rolled a standard die 51 times, right? And so she rolled a 5 12 times. The experimental probability of rolling a 5, we take it straight from here, what actually happened, right? That's when actually happened and should happen. That's when those statements come in. So 12 out of 51. Theoretical probability of rolling a 5, right? It's a standard die, so there are 6 options. So one of them is a 5. Everything except a 5 would therefore be 5 out of 6, right? So there you have these should add up to 100% or 1 or a full fraction, right? We're going over the quiz. Here for 4, you know what? I realized that you haven't voted, so you don't necessarily know the parties, right? But if you have a 45% vote, you're most likely going to win the election because there's quite often more than 2 parties, right? Most of the time. So that was not what I wanted you to focus on. I wanted you to focus on the 100 people, right? So the sample size, like if you ask 100 people and you now want to like predict for the whole country, that's too small, way too small. Like you would have to make note of that, right? We're talking millions of people, so you should probably be asking a couple thousand. And I would have to add that you have to diversify. You can't just ask a couple thousand if they're all seniors. It's going to be biased, right? You should be asking, younger people, working, not working, different income, right? Income levels. You consider all of that. But that's an aside. We're going to focus on sample size primarily. Okay, next page. That's where some of you need to know how many cards are in a deck of cards and so forth. There are 12 face cards. So when there's a color being talked about, it's half of them, right? So 6 out of 52 drawing a black face card. Drawing a 4, 5, or a 6, there are 4 of each. So it's really 12 out of 52. Red queen, there are 4 queens. 2 of them are red, 2 out of 52. Okay. I hope you make corrections. I'm taking the time to go over this, right? Question 6, 35 marbles, they're red and white. 14 of them are red. Okay. What's the probability of getting a white marble? So you needed to take the 14 away from 35 to get 21 out of 35. And here's the kicker. If you draw and do not put it back, if you see that that's dependent, right, then we know that these two events are depending on each other. What's the probability of drawing another white marble? Well, it actually, you take a white one away, so from 21, you go down to 20, and from 35 total, you're down to 34. Okay, so your probability actually went down a little bit on the second draw. So this one, I don't know if you noticed, most of you would have turned this into a 2-mark question, and that was reflected on the quiz as well. Next, you had to figure out the probability of people voting for Patricia. Obviously, it's 44 over 120. Most of you got that. And then to predict, you take that probability and multiply by 1985, the total number of students there. So 727 votes or 28. As long as it's a round number, you're fine. Okay. Next page. This one was a little wonky, to say the least, right? Let's talk about the explanation here. Explain how you know that events are dependent, right? When the first event affects the outcome of the second, right? So when items are not replaced, you can also say when the total possible outcomes are being reduced. Does that make sense? If I flip this coin, every time I flip it, there's still 2 options every single time. Nothing changes. So a coin is not a good example of dependent. Even if I flip it 10 times, right, those 10 events are independent of each other, right? If you now talk cards, right, there is a potential for events being dependent, because if I draw one, right, the total number of outcomes is being reduced every time, right? Unless it does tell you that you're putting them back. If you put things back, then they are actually independent because you reset everything, okay? So Gurpreet draws a card from a standard deck of 52 cards. He draws a queen of diamond. This is happening, right? This happened. Does not replace the card. Then draws a second one. Determine. If you're talking probability, every single one of them should have had a 51 on the bottom, right? Immediately you should recognize there's no replacement, 51, 51, wherever there's a probability. So probability of the second card being a 5, the 5s have not been affected, so there are still 4 out of 51 left. The probability of the second card being a queen, well, a queen has been removed, so instead of 4, you have a 3. That's why this is worth 2 marks, because you have to change that and that. The probability of the second card being a face card, there used to be 12 face cards, right? 12 minus the 1 queen, that's where the 11 comes from, right? This queen of diamonds is, are you paying attention? Yeah, you are? Okay. Queen is a face, right? It is a diamond, right? And what if diamond is what color? Red. So when I give you this, I'm actually giving you 3 pieces of information there. That it's part of the face group, Facebook, face, part of diamonds, and part of the reds, right? So if anything like this is talked about, it's going to be affected, right? So face card, yes, the queen of diamonds is a face card, so we are with 11 now. The probability of the second card not being a queen, so what you need to do is you have 51 cards, take away the number of queens that are left. given that a queen has been removed already, right? So you're down to 3. So that's 48 out of 51. Then we have Anthony rolled a 12-sided die 30 times. It landed on 7 on 11 occasions. This is an experiment right here. Okay? Experimental probability of rolling a 7, right? It would be 11 times out of 30. Theoretically, 1 out of 12. There's only one 7 in a 12-sided die. And you make a prediction. Get this right, please, because even if you get this wrong, let's say you got this wrong, but if you use that number here to make your prediction, you still get the mark. You need to use the theoretical probability to make a prediction. Don't use the experimental. Do not use this one. Okay? So that's why a mark, this was a mark, picking the right one, and then multiplying them is another mark. Okay, Emma has a jar containing a bunch of candies, not marbles. She picks a random candy and gets a blue one. She replaces it. Did you see that? Meaning this turns into independent events, meaning nothing changes really from one event to the other. No changes, okay? State the probability that the second candy will be red. You still have 16, you still have 5 red ones. State the probability of the second candy being a blue one. We still have 4 candies, even though, see, that's why I don't buy bulk candies at 7-Eleven, because that's what happens all the time. People put them back. Kids grab one, it's like, oh no, I don't want that one. I want the other one, right? Gross. 4 out of 16, 1/4, right? So that's still 1/4. So now we enter the last page of our quiz. Odds. Please read carefully. Read carefully. Is it probability? Is it odds? Odds, right? Okay, I know what it's supposed to look like. As soon as you have odds, you will have this, and you have 2 numbers like this. Okay? So, with the odds in favor of drawing a pink marble, you want the pinks on this side and the ones that are not pink on the other side. I counted that they're 19, so I just go 8 pink, therefore 19 minus 8 will go on the other side. No total, guys. No total for odds. State the odds against drawing an orange. When it says against, that means that the oranges will be here. Everything that isn't orange is on that side. Mr. Dirksen, you're adding. You always tell us about subtracting, what's going on there. What am I adding? The ones that are not orange, right, on my pile, the 8 and the 4. So you could have gone 19 minus 7, you still get 12, right? Regardless of how you do it, you get the same. State the probability of drawing a pink marble, 8 pinks, 19 total. Probability, not odds, okay? The Jets play against the Senators. The odds of the Jets winning are 3-2. If it says odds of or in favor, that means that this is winning, right? Winning, not winning, okay? So the odds against the Jets winning, you just have to flip it. You take that one, you flip it. If you already have the odds, just flip them. State the probability of the Jets winning. So I go get my winnings, which is 3, and the denominator is always adding them up, right, to get the 5. 2 out of 5 of not winning. And the last question here, Mary draws a 4 of hearts. What do we know? It's a 4 and it's red, right? And it's of the hearts, right? The suit of hearts. Couple things. Does not replace it. Oh, dependent events, right? What's the probability of the second card being an ace? The 4 of hearts does not affect the number of aces, right? So there's still 4, but I'm down to 51. Probability of drawing another 4. Well, the number of 4s are down because you already grabbed one, and we're still down to 51. And then it states the odds of the second card being a face card. The 4 of hearts has not affected the faces, so there's 12. On this side, you must start with 51, not 52, because you're down a card, and then just subtract the number of faces, so it's 12 to 39. And then the last one, Joseph draws a 6 of spades from a standard deck of cards, replaces it independent, right? What's the probability of drawing another 6? It's still 4 out of 52, right? So that's how you got your marks there. This video will be up, so if you want to slow me down, right, you can slow me down on YouTube and go over it a bit slower.